transparent. That might be- Okay. Um, so again, this is a course ID and enrollment key for the half credit site, which you can use anytime to do an assignment for half credit. Okay. Now, if you've already done it and you do it for half credit, well, you're not going to get that half credit plus what you got. Okay. But if half credit's better than what you made on it originally, I'll change it. Okay. And if you weren't able to get the assignment done, if you just forgot it or one thing or another, then it happens. Don't want to use a late pass, you can do it for half credit and I'll transfer your grade over. And if you have a good excuse, now, you know, if for the sixth time you tell me your dog ate your notebook, I'm not going to believe it. Okay. But if you got a good excuse, and that could ask for doctor's excuse and stuff like that, or something else, usually I'll trust you in the first couple. Okay. Then I transfer your grade for full credit. You're not going to be able to do it on the original open math page after the due date. Cut off. Okay. And I'm not going to change that. But the half credit pages there at least give you half credit. Okay. Also, the half credit pages there for extra practice. I haven't looked at your quizzes yet to see if you need extra practice, but it's there if you want it. If you want to use it, I recommend that you do if you didn't get 100% in that quiz or close to it. Or maybe you'd be better off just reviewing the notes and stuff, but it helps to do practice to get feedback. Okay. I also wrote a program that allows me to randomly generate millions and millions of practice problems. If anybody wants a million, well, I'm not going to give you. File will be too big. Okay. 10,000 would be enough, wouldn't it? Okay, well, you get it. You get the idea. Okay. Okay, so well, let's go over these and see how you did. Okay. We got 2x squared. I'm going to write this as y equals 2x squared. Matter of fact, I'm even going to write this as we're going to introduce function notation today. And you should have seen function notation. But I will tell you, I went to the kind of school, if you get into, everybody in the hall is congratulating you, and they're all your enemies the day before. Okay? It wasn't the top elite schools in the country. There are about half a dozen of them. There's in the next notch down. Oh, schools like Virginia Tech. Okay, it's a good school. And probably a little higher reputation in the area than Virginia Tech enjoys, but I don't think it was a whole lot better than Virginia Tech or worse. I think that's so it's a good school. And I done really well in my SATs. I think the only thing I missed was about function notation because I'd never seen it. And I had a really good high school. I mean, I had trigonometry, algebra, everything. I had it down completely. I was sure that I hadn't missed anything on any graph from the SAT. But I hadn't seen function notation, and it kind of threw me for a loop because they don't offer pre-calculus at the school. Nothing below calculus. And nothing below really tough calculus. Okay, so I had to go in there and conjecture function notation. I didn't do real well. I mean, I got by okay. Yeah, I started doing real well the second year. But I had to make up just for the fact that I hadn't really had pre-calculus course. Okay, but I'd have intense courses and everything else. So I was able to overcome that. Dumb as I am, I was able to overcome that. But so the point is, function notation is real important. So we're going to introduce it today. Hopefully, you've already seen it. Hopefully, you're in better shape on function notation than I was when I started out. Okay, so I'm going to write y equals f of x equals qx squared. Okay, if you don't know what that f of x means, well, you've seen it at least, and I will explain it in a little while. Okay, so then Uh, okay, anybody have a question about that? Sometimes negative signs throw people and stuff, but if you square a negative, then you're multiplying a negative by a negative, it's going to be positive, right? I assume everybody knows those rules, right? If you don't, probably don't want to admit it publicly, but let me know, okay? We'll arrange some tutoring for you or whatever it takes to get that done. Okay, if y equals 1/2, now, one thing people will sometimes do is they'll multiply the 2 by the 1/2 and then square it. But the order of operations says you do exponents before you do multiplication, right? So it's a common mistake. It's real easy to do. Okay. So you want to catch yourself in that. You want to make sure you're following the order of operations. I assume you know what I mean by that. And if you don't, you might want to look at the videos I'm posting for the intermediate algebra course. Because we just talked about the order of operations and how it applies to fractions and other things. I will be posting those videos where you can find them. Okay. Actually, you can find them anyhow. You know where the main assignments page is, the one you click on to find your own assignments page, and then you bookmark that, right? Just click on the intermediate algebra. It's all there. Okay. And my experience is that there are things in that intermediate algebra course that you really need to see. I think the intermediate algebra course even has all the videos from spring and probably even fall of last year. So you pretty much find whatever topic you're looking for if you just kind of look at the titles. Okay, so okay, there we have it. 2 times the square of 1/2. Well, that's 2 times 1 squared over 2 squared because the exponent distributes over a division or multiplication, right? Okay, you gotta be sure you understand that. And that equals 2 times 1 over 4, which equals 2 over 1 times 1 over 4. Going a little overboard on the details, we want to make sure we understand. So now when you multiply the numerators and you multiply the denominators, and then you reduce that to 1/2. And I won't go into all the detail about that reduction, but you can divide the numerator and denominator by the same number without changing the value. 2/4 has the same value as 1/2. Okay. Oh, you can multiply it by 738. Now, you were inclined to do that, weren't you? Okay. So what you get is 1,476 over 2,944, which has the same value as you well know. Okay. My point is, those are rules. And you want to follow the rules and you want to be explicit about how you follow the rules when you write things out. Okay? If you have time. Now, if you're on a test, I still want to see steps of your solution, but I don't expect you to go in quite as much more in detail here. Okay? If you just say it's 2 times 1/2 quantity squared, and you want to say then 1/2 squared is 1/4 and multiply that by 2 without having to write 2 over 1 times 1 over 4. I assume that you can do that. Now, if you start making mistakes, I'm going to tell you, you really ought to be writing that out until you don't make those mistakes anymore. Okay. Now, I'm going to write these out using function notation. Okay. Because I want to use function notation to solve the rest because it's more efficient. And that gives you one reason for understanding function notation. So here I'm going to say the same thing I said over here, but it's going to be shorter. If x equals -2, then y equals f of -2 equals this. Actually, it's not all that much shorter. I don't know what I thought it was going to be, but it wasn't. Still, I want you to see it because I'm going to explain more about how to use it, because you're going to have an assignment on that due, I think, Saturday. Now, it's a weekend. It's a long weekend. Try to get your assignments done on the weekend so you can have a good week. Okay? But, you know, balance it out as works best for you. There'll be 2 assignments this week. Okay? Now, I don't really, here's how we get short. Okay? You want to evaluate it for 1/2. All you really have to do is write f of 1/2 equals, actually it's 2 times 1/2. And whatever the number is, you put it in the parentheses here where x was. Because x is 1/2, you put 1/2 in here. And that's what it means then. You got the 1/2 here where x was. You put it where x was in the formula for the function. Okay. So if you haven't seen it, that's not a bad way to understand it. Well, I'm not going to write out the details. That is 1/2. And then I'm going to write it this way. F of -8/3 gives 2 times -8/3 squared, which is 2 times 64/9 without writing the 8 squared over 3 squared, but you should see that in your head. If you're not seeing it in your head between this step and this step, write it out until it automatically comes into your head so that you don't screw something up. Okay? So you're less likely to screw something up with cube when we screw things up. I never did that. You're going to see me screw up a lot of things. Okay. So we got 2 times 64/9, which is 128/9. Doesn't reduce by factorization and all that stuff, which we'll talk about. F of A is what? Well, x is now A, so x is A. So we write 2 times A squared. Once that's 2A squared. Okay, don't need the parentheses. But we do probably want to put the parentheses there because another common thing people do is they multiply the A by the 2 squared. If you put the parentheses there, it reminds you, no, I'm not squaring that 2. That 2 doesn't have a square on it. Okay. Yes. Okay, then F A plus V equals 2 times the quantity A plus V squared. Now, that's actually sufficient. So I did look at all the paper one. I saw it said 2 times an A plus B times an A plus B. That was good. Okay. I don't think you finished it, but you weren't asked. Okay. I'm happy just to see that right now. But I will tell you that A plus B quantity squared is A squared plus 2AB plus B squared. It's not A squared plus B squared because exponentiation, while it distributes over division or multiplication, does not distribute over addition or subtraction. Okay? These are profound words. You got to replay them. You don't hear everything I said. Replay them. Look at the transcripts of these things to see if they're any good. Also, I've looked at the screen lately to see if my profound words are being recorded, because right now they are. Okay. I don't know what's the matter with these people. I mean, seriously, that's really dumb. Not having anything on the screen that tells you whether you're recording or not. You get privacy violations all over the place. Okay. I used to like Zoom, but I'm looking for an alternative. As soon as I find one, I say goodbye to Zoom forever. I know there are alternatives. I just haven't had time to try. Okay, so anyhow, that takes care of this one, right? Now, it gets a little more complicated with an expression like x squared plus x to the -2. So, Now, the name of this function was f. Okay. I can make up any name I want. Okay. I could say y equals aardvark of x. If I want to use aardvark for the name of my function. I don't know why I'd ever want to do that, but I could. Now, usually we make it brief. We use some kind of symbol, usually a letter of the alphabet. So I used F. The next letter in the alphabet is G. Is that right? Everybody know the alphabet? Okay. Okay. Seriously. So I'm going to call this function G. The rule's the same. Okay. G of -2 equals what? Well, there's -2. It replaced x. So -2 replaces x. And I just write out the whole expression. Look at all those 2's and -2's. Okay. Well, it's pretty easy to do this. If you know the rules, -2 quantity squared is 4. The negative exponent tells you you do the reciprocal. And I did have a nice explanation of why that is in the intermediate algebra. It's worth looking at. It's short, sweet, and it gives you a lot of insight into why the rules of exponents are. It's not complete, doesn't explain every possible rule, but I kind of recommend it. I think it worked out pretty well. And I think people pick it up pretty well. Gives you a little deeper insight instead of just here's the rule. Why is that the rule? Okay. You remember the rules better if you understand why they make sense instead of just blindly following them. And unfortunately, a lot of our curriculum is just blindly follow this. We don't have time to think about it. And don't practice it too much so you don't learn it. Okay. Because we don't want you to take time away from your social media. Okay, or whatever. Okay. That's not really what's going on. But there's some flaws in the way things are taught. So you've got to want to be aware of that so that you can prepare yourself that. Okay. And it's not your teacher's fault. It's the way the curriculum is designed. It's also the culture because people don't want to spend much time in their education. So what are you going to do when you got a class full of people, 2/3 of whom don't want to spend any time on it at all? Am I right about that? I mean, am I right that, like in your algebra 2, algebra 1 classes, most people really didn't want to spend time and did a mill. And then there are people who have enough sense to sign up for this course. Okay. And I say you probably weren't in that category, although you might not have been enthusiastic about it. When I was in high school, I was enthusiastic about reading history, but I, enough of it to make a decent grade. Okay. We have 1/2. So that's what we say, okay, we'll try to evaluate it for x equals, but it's 1/2, okay? So g of 1/2, we replaced x by 1/2 throughout this expression here, and we get 1/2 squared plus 1/2 to the -2 equals 1/4 plus 1/1/2 squared. Now, what's that? Well, first thing we do, we don't worry about what's going to happen next. We see that -2, then we do this. Okay. Then we got the 1/4. And we can square 1/2. Be okay with that. 1/1/4. I'll kind of put parentheses around it. It's not really necessary just to indicate that is the denominator. 4 is not the denominator of this fraction. 1/4 is the denominator. But we don't want a complex fraction. We don't want a number or a fraction divided by a fraction. Okay. So what we do, make the reciprocal of that multiplied by it. Now that's a rule I know you've seen, but people kind of lose track of that. Don't get enough reinforcement or whatever. Don't understand maybe why it's so they don't really understand. I'm not going to explain why that one is so, really not in this course. Probably explain it to some extent in intermediate algebra. You can prove it has to be so, but I don't want to get into the proof. It's not a big proof. Okay, so what else do we have? Well, I'll write these out more quickly. G of -8/3 equals -8/3 squared plus -8/3 and -2, which equals 64/9 plus 1 over 8/3 squared, which is 64/9 plus 1 over 64/9. I didn't use the parentheses here. Sometimes you maybe make this little line bigger, but you note that's in the denominator. Equals 64/9 plus 1 times 9/64 equals 64/9 plus 9/64. Now, of course, you would, in many cases, want to put these over the common denominator, add them up. Okay, this comes out 17/4, so 9 times 64 is 196. No, 576. And the, yeah, 64 squared is 4,000 times. Power 2. Okay, well, anyhow, you don't know that, but how do you know this? Okay, so there you have it. Okay, then what's after that for G of A? Well, I replace X by A, I get G of A equals A squared plus A to the -2, which is A squared plus 1 over A squared. Not much more to say about that, except you could do the common denominator, be A to the 4th plus 1 over A squared. Okay. Then I'll write that down, just not going to explain it. But you can see that this has to be the same as this after I break it down, because A to the 4th divided by A squared simplifies to A squared, doesn't it? And then plus 1 over A squared. There it is, right? Incidentally, people tend to cancel this and cross out the 4 and put a 2 there and not do anything with that 1. The 1 is also divided by A squared. And I see a lot of cancellation like that. Okay, which is why I don't talk about cancellation much. Till we get a little more depth at the algebra. Okay, but there it is. Now that's function notation. That's enough to get you started on function notation. Okay. Now I'll take a look at the assignment, make sure that there's not some curveball in there. But if you understand that much about function notation, just that if you write G of whatever, then you replace all these X's with that whatever and do what follows. Okay. Now there's more to it. You know, how does that relate to the graph and stuff like this? I don't think that something you're going to encounter inside, but it might be. So I'll take a quick look to remind myself. Should have done that when I had all the extra time this morning. There's a lot of details coming out of the woodwork here, no excuse me. It'll be the weekend before I get everything completely on track. There's still some errors in the course of study. None that I didn't talk about last time. Okay. Now, we can talk more about that, but let me make sure. Where in the world? Is it this one or is it that one? It's that one. Okay. Now, especially if you're not in my class, you might already be looking at parent toolkit functions. Anybody seen those in their class before? See them? They do this weekend or they already do? They do this weekend, say yes.
I just started mine.
These people out in the hall keep trying to answer my questions. They walk by when I ask a question and start talking. This weekend, next week, okay, sometime. Okay, anyhow, we're going to give you an introduction to that. And there's nothing embarrassing in that except that you talk when you shouldn't have, but everybody knows that. Okay, so there's no problem there. I'll use the word toolkit. There are several. Sometimes they're called parent. Sometimes they're called basic. Okay, those words are interchangeable, but they're the functions on which everything we do in most of undergraduate mathematics, even for mathematics, well, not so much for mathematics major, engineers, for example, build almost everything on a small handful of functions. So, as soon as I find the Zoom meeting, we're still recording. Okay. Just your squaring function. Okay. Now you've seen quadratic functions. You see that now number one. The quadratic formula together. Okay. And incidentally, when I went to that really good school, I think half the class didn't remember the quadratic formula. Okay. So I felt a little bit superior to at least some people. But of course, at a school like that, there are people that make anybody feel inferior, so you don't want to get your big head. Okay. If you got one, you get it knocked off real quick. And I knew that already. I knew people would smarter. You learn a lot by people, some of those guys. And I say guys when I go back to that because out of 1,600 people, there were only 12 females. That's reverse no. There are more females at that school than there are males. And that's good because eventually guidance counselors and so forth discovered that females can do math too. Ridiculous. I knew it. You know, I had the top SAT scores and the top National Merit Scholarship scores at my school, but it's only because Mary Jo Casino majored in secretarial science. She was way smarter than I was. So I knew I wasn't at the top, and I knew the women could be. Just figured they just didn't want to be. More systematic reasons. Okay, anyhow. And I think the majority of PhDs turned out by that school in mathematics are female. And they're very good. Okay, so anyhow, quadratic. And then there's reciprocal. And there's, I want to do exponential. Yeah. So we do reciprocal square. Abbreviating reciprocal. And that's just like the reciprocal, except for squaring the x. You can have a reciprocal cube and a reciprocal fourth power and stuff like that. But these functions are enough to get you started. And you got a cubing function. So the cubing function is just like the square function, except you got one higher power. And the reciprocal square is just like the reciprocal function, except you got a higher power in the denominator. Power is one higher. Okay. And the graphs have a lot in common, but they also have some differences that are important. We're not going to talk too much about those at this point, but we'll talk about them later. Okay. Now your book will tell you to use your calculator to evaluate these functions. I don't even allow a calculator to live in my class, but in your class, maybe. Okay. So when you do these problems, don't use your calculator unless you absolutely have to. You already learned how to evaluate powers, and we evaluated reciprocals. Okay. And your book is going to tell you to use numbers like from -3 to +3, including some fractions, which isn't bad. That's fine. I'm going to confine it to the following domain. Sorry, I switched from cursive and cursive. I started writing cursive again this year. Used to, it got to the point where I was writing so much of it that I got like a permanent writer's cramp. But now that I'm approaching my prime, it's going. Okay, so using the domain. This domain and accepting numbers that don't work, and we'll see what I mean. Like what's 1/0? Well, you should know that that's undefined. It's a DNE, does not exist. Okay, and there's a reason why 1/0 doesn't exist. I'll probably talk about it, but right now, and you put it in your calculator will yell at you. Maybe it'll explode. I don't know. So don't put that. Don't do 1/0. Could be dangerous too. Okay. I don't use calculators. I use my head, or I use the computer if I have to. I do a lot of stuff in my head. Not always accurately, but I can do it. Okay. Y equals f of x equals x squared. So let's make a table. And I guess I better come over here. I've got more room. I'm going to write out y equals f of x equals x squared. Okay. And then I'm going to put all these numbers here. Now, we already evaluated x squared. There's a method to my madness. I've already used an x squared in the examples. Okay. And it, I think, amply illustrated what we were trying to illustrate. But now we don't really have to go through the details of how to calculate x squared. So we know, well, let's just write this out and then write the y numbers in. Should be able to do that relatively. Okay, I'm not being mean or being critical. I'm just telling you, if it took you more than a minute to write those numbers down, you don't know your numbers well enough, and you need to be writing all these out every time you do them for the foreseeable future. Don't rely on your calculator. If you rely on your calculator, you never get a sense of numbers. And if you never get a sense of numbers, I don't know how you get through life. Okay, that's kind of a quote from one of the other methods. You know, financial decisions. So just rely on the calculator. Without having some common sense of the numbers, you're really at risk. And you better hire somebody to manage your money. That costs money. Not that hard to learn. Okay, that's how we have a good shape with this, but the results are, hey, and some of you are writing it out this time. I'm going to write it out this way. Okay. Reinforce the function of f of -2 equals -2 squared equals 4. Right? You just saw that. Okay. Now, not saying there's anything wrong with you, but there isn't. Yes, you're here. Something wrong with you, you wouldn't be here. Okay. But be aware that you really need to know that a lot of you don't appear to know very well. And it only takes practice. Like grandson is learning this in 5th grade. Okay. And he's no genius. Pretty good at math. Not the top of his class or anything. Don't think. Okay. So you write it out. And you write out f of -1/2 equals -1/2 squared equals 1/4. And you write out the intermediate steps so you know what the rules are. Now the rest of them, we got 0, 1/4, 1/4. Okay. Okay, then we have the reciprocal function. I'll still use F. This one. It's a different F than this one, but we're done with this one, so we call this one F if we want to. Same numbers. You've seen the rules. Now, if you could write them down accurately, just in your head, and some of you I think can, that's okay. If you need to start with f of -2 equals 1/-2, right? And this is again that equals -1/2. So see if you can write out the rest of them. Before. I'm learning its tricks. So hopefully I'll stay on track, but I lost a whole lot of one class. Because student doesn't tell me whether I'm recording or not. Okay. Yeah, -1 equals 1/-1. I should probably put parentheses around this and make it there. But that's -1. F of -1/2 equals 1 over -1/2, which is negative of 1 over 1/2, which equals negative of 1 times 2 over 1, which equals -2. Now that's taking up a whole lot of space, but that's the process, and every step of that process is something you need to understand, because this is elementary school arithmetic. Okay, so at least middle school, I don't know what's elementary anymore. Now, what about 1 over 0? Well, let's think for a minute. I'm going to leave this blank for a minute. I'm going to do f of 1/2, which is 1 over 1/2, which is 2. And it's just the same as this one, except you don't have the negative sign. Okay? So we'll just say same process, same steps, but you don't have a negative. Another, how many 1/2s are there in 1? I got half of something. How many of those do I need to make a whole one? Hold up your fingers. Yeah. Yeah. Both fingers in the same hand to avoid the temptation. Okay. Now, okay. How many zeros does it take to make 1? You got nothing. How many of those do you need to make a whole one? You don't need 0. If you have 0 of nothing, you still got nothing. You don't got 1. Okay. How many zeros does it take to make it? It can't be done. I don't have room to write can't be done. It's all right, DNE. It's DNE not because your calculator tells you it's DNE. It's DNE because you understand that you can't make 1 out of nothing. Okay? And that's important. Going to be very important in latter part of October when you deal with asymptotes of rational functions. You've got to understand it now. Okay. And then, okay, the rest of them, you get 1 and you get 4, and I'm not going to write out the details. You get that immediately, okay? Oh, wait a minute, this is 1 over x, so it's 1. What happens when you do things too fast? I just pretended to make a mistake there, but I want you to understand that sometimes I really do mistakes. And now I realize I've made another mistake because this table isn't visible. I've stopped looking at the screen because it doesn't tell me anything. Okay. Actually, it still is telling me, so maybe there's something I can do. Like, I don't know, why did it stay up that time? Ah, that's not relevant. Okay. Maybe I'll get used to it. Okay. As I said, if you use this domain and try to do the square root of x, you get numbers that you don't know how to calculate. What's the square root of 1/2? Okay. It's about 0.71. Okay. About the reciprocal, it is a reciprocal of 1.414. Three significant figures. And 1.414 is the square root of 2. We didn't know that. Everybody in my generation did because we didn't have calculators. You had to use it. But there's no compelling reason why you should know that. So you're going to have to maybe use your calculator. So what's the square root of -1? But let's talk about that for a second. Okay, now when we talk about the square root function, Open Math is going to say use your calculator. That's not what I say, but Open Math. And I don't object if you have to use your calculator for a couple of these. Okay, so like what's the square root of 4? 4 isn't on this list. Well, there are other numbers on the list. And maybe over mess was up to 4. Okay, what's the square root of 4? Well, it's the number you multiply by itself to get 4. We've already been through this. And you know what do you multiply by itself to get 4? 2, right? What do you multiply by itself to get 2? You can't tell me. I can't tell you exactly, because that number is it expresses a decimal number. It never ends and it never repeats. Okay. It never ends and it doesn't have a pattern that continues repeating forever. Okay. If it had a pattern continued repeating forever, it'd be a fraction, and you could express it. Okay, it's about 1.414. If you square 1.414, you get something very close. Okay, but you don't know that, and you don't need to know that. All right. Well, so when you're making the table, if 1/2 and 2 are in your domain, use that word domain. Domain is the numbers that you plug in. Here's your domain. Here's your domain. Okay. Let's go back for a second. Notice here we have this one result that doesn't exist. What's that mean? That means that 0 isn't in your domain. Okay? Because what I said, the domain is this set of numbers, accepting numbers that don't work. Well, 0 doesn't work. Okay, well, what do you think the square root of -4 would be? Well, it's a number you multiply by itself to get -4, right? It's not a real number, because if it's negative and you multiply it by itself, it's going to be positive. And if it's positive and you multiply by itself, it's going to be positive. You can't get a negative by multiplying a number by itself, so you can't have the square root of -4. Okay? You really have to understand what a square root is, what it means, in order to follow that reasoning and to use that reasoning anytime you're tempted to take the square root of a negative number. You have to use your calculator. It'll give you an error or give you some kind of message. You know, somebody, yo, fool, you can't take the square root of a negative number. You know, well, they don't say it like that, because some people take offense to that. I think it's kind of fun. Okay. What about 0? Anybody want to tell me what the square root of 0 is? What do you multiply by itself to get 0? 0 times 0 is 0, so the square root of 0 is 0. All right. Okay. Now you're probably going to see graphs. I hope you know how to locate points on a graph. But just in case you don't, let me go ahead and locate these points. Now to make the graph using my domain over here, it's not my domain, but the domain that I prefer to use for these things. And the domain that your text uses just a little wider variety of numbers. Okay, I think this is sufficient. I don't want to overload people. Okay. And if you're going to use that wider domain, you're probably going to tell people to use a calculator so they never have to think about numbers again. All right. Well, that's not your goal, obviously. So not use the x-axis and the y-axis. You know, well, I screwed that up. Hang on. One has some negative numbers in this thing. I didn't leave myself room for negative numbers. Okay, I've got the x-axis. We'll put the y-axis kind of in the middle. And we'll leave room for some negative y values. Okay, so now I'm going to say, okay, let's say here's -2. And I go to equal distance over here. I would say the two's about there. Now, one is halfway between 0 and -2. So we cut that interval in half, right? -1, that is. -1/2 would be halfway from 0 to 1. So here's -1/2. And I don't want you using your calculator to make these graphs. Okay? For your sake, I advise that you don't use a calculator, even if your instructor in your pre-calculus class says it's okay. In this class, it's not. Just for your benefit, so you learn stuff. And if your instructor says it's not okay, it's not that I think your instructor's telling you wrong, because our other instructors are quite good. It's going to want you to understand a little better than you otherwise would, and I think to do better. Okay, so we make a graph. No, late, so I'm going to go quickly. I see that my range, my y values, go from -2 to 2. So my y value here is 2. My y value down here is -2. So here's 1 and here's 1/2. I'm not going to take time to label them, but it's going to look like that. Then -2, x is -2, y is -1/2. This line here, the dotted line, is for x equals -2. Every point on this line has an x coordinate of -2, right? And every point on this line has a y coordinate of -1/2. So there's my point. Now I draw the line x equals -1, and the line y equals -1, and I put a point there. And then the x equals -1/2. And the y equals -2. We have this. And then we do the same thing up here. I'm not going to label the lines. So I get them. So we look at the table, make sure that these coordinates match, and we get these 3 points. Okay. Now we can take a curve here, and we can take a curve here. We can't connect the left-hand side with the right-hand side. If I try to connect it, let's say I just go straight from here to here, I go through the origin, right? Then that would say that when x is 0, y has to be 0. But when x is 0, there is no y, so you can't go through the y-axis anywhere. Because if you did, you'd be saying that 1/0 is whatever the coordinate of that thing is. Okay? So that's just one example with a little idea. If you keep getting smaller numbers, you keep getting bigger numbers here. If you keep getting bigger x numbers, you get smaller y numbers. So this thing spreads out and has what we call asymptotes with the y-axis and the x-axis. Now there's your introduction. I think with what Open Math gives you, you should come back next time with a pretty good picture of this function. In my class, we're starting with pictures of graphs. We haven't even looked at numbers yet, but that's, so for those of you in my class, you're going to learn something about the numbers because other classes are going to do it, right? We've got to cover all the classes. Okay, well, very good.